Right, question 6. We're given a table here, nicely moving into extra value columns. Sometimes that doesn't happen. So we're working out the mean speed. So for the mean speed, we have to take a midpoint of these values because we're guessing what the speed is roughly for each of these 7 drivers or cars. So we're going to take the halfway point of these, and then we're going to create something called an fx column, which is this number times this number. So we're going through times in these numbers here. We then add up this, and this is the total miles per hour that have been driven. And this is the total number of cars, which we already knew because it's in the question. Once we've got those two values, then to work out the mean, it is the total fx, never ever at the midpoint. So it's the total fx divided by the total frequency, which will then give us 51.8, and I presume it's miles per hour. It actually doesn't say. Kilometres per hour it does. Kilometres per hour there, says it in this part there. Question 7. Cumulative frequency question. Cumulative means accumulating as we're going along. So if we've rolled from 10 to 20, I say roll because I think it was a snowball at the top, rolling from 10 to 20 here, it rolls along, it picks up 4 bits of data, then it picks up another 7 bits of data, so we've got 11. Add 11 to 13, you get your 24. Add your 12 to your 24, you get your 36. Add your 4 to your 36, and then you get 40. We then plot these at these top values. Why does that make sense? Because you need to roll all the way through this region to get all 4 values. So we start at the bottom value here, which is 10, so our first point is going to be there. Then we're plotting 24. Then we've got 30, 11. We've then got 40, 36. And when we've got 40, 36, we've then got, sorry, not 40, 36 at all. Thought that was a big jump. We've actually got 40, 24. Then we've got 50, 36. And then we've got 60, 40. And it's asking us then, let's just have a see from here, draw the cumulative frequency graph from your table. So from this value here, not a bad effort for me with this curve, shame about the flick at the end. Your curve should slightly bend a bit better than mine does, but with the equipment I'm using, that's not a bad effort at all. Then it says, use your graph to find an estimate for the median length of these TV adverts. So median will be, if you've got 40 values there, 40 values you add 1 and half it, so it'll be the 20.5th value. So we go across just above 20, can't really tell the difference between that and 20 to be perfectly honest. And then you go downwards. So there I'm going to go for part C. My answer is 38. They will accept anything from 36.5 to 38. So I just about squeezed in. Question 8. 23 girls have a mean height of this, 17 boys have a mean height of that. Work out the mean height of all the children. Right, so if 23 girls roughly weigh 153 each, that'll tell you the total if you put them on top of each other. And 17 then times by 165. So 23 times by 135. That's the total number of centimetres in the girls. And that's the total number of centimetres in the boys. Weigh them together. And then how many people have we got in total? Well, we've got 40. So it'll be then be the total height overall divided by 40. And that will then give us probably, I would say, let's go to 0.1 first, then I'm going to round it to the nearest centimetre, just making sure that I put the whole data in there. Question 9. So we've got a statement here about lowest, highest, upper, lower, median, and we're asked to draw a box plot to show this information. So step 1 is the lowest value is 2, so we draw a little line at 2. The highest value is 6.5, so 5 squares in. Similar sort of distance in terms of height there. Then the lower quartile is 2.8, so this one is a slightly larger value. We've got then the median is 3, so very close to each other, so it's the same height. And we've got the upper quartile then is 4.2. Obviously you'll be able to draw it a lot more polished than I have. But there you go. Straighten that up, I can't handle that. But the edges here, you know, obviously you'll be a lot smoother than that. And then it says there are 60 babies. Quite a common question this. It likes this. Likes to ask something about the quartiles normally. So I've not read it yet, but I presume it'll be that. Work out the number of babies who weigh greater than 2.8. Well, the lower quartile is 2.8 there. So if that's 2.8, then what we've got to do is how much data is above the lower quartile? Well, it's the lower quarter. So 25% of the data is below it. That means 75% of the data is above it. So if we've got 60 babies, 25% of that will be dividing it by 4, which is 15. So how many babies will be above? 60 take your 15, which will then give you 45. Important it says above that weight. Again, clever there. You usually say below, so you just use the quarter and that'd be answer. They're saying above it. Question 10. First of all, we've got Simon here is designing the questionnaire. And for people who visit sports club, he wants to find out how often people visit sports club, design a suitable question he could use. Now, the important bit about this question is how often do you visit the sports centre? If you just put that down, useless question, because you're not sure what the time frame is. You know, is it meaning every year, in a month, in a week? So you then just put a time frame in. So put in a week or in a month. That's fine. And it's a 2 marker. So we've got 1 mark for the question. We'll go for 0, 1 to 2, 3 to 4, 4 plus. Sam asked his friends who visit the sports club to do his questionnaire why this might not be a suitable sample. It's biased. Why his friends may exaggerate or may choose answers to make him feel better. There's the fact, the emotional side there. Other answers you can say is it's sample's too small. It's not a random sample, which is correct. Part C then, we've got 365 runners in a sports club. Table of information about this runners, number of male, female in the years. Surveys the runners in the sports club. You use a sample of 50 runners. Work out the number of male runners with an age of 30 to 39. So here's the male runners. So how many in his sample of 50? Well, all you do, you take the 45 out of the total and you times it by your sample size. So 45 divided by 365, times it then by 50, and you get 6.16, etc., and that'll round then to 6.